This is an introduction video on mathematical induction. You will be given a question for Combined Mathematics 1 paper under Part A, which carries 25 marks out of 1000. Mathematical induction is a way of proving things. You will be given a statement, a mathematical equation, or else an inequality. You have to prove that statement, inequality is true for all values of n. Mathematical induction proving method contains 3 steps. Step 1 is showing the statement is true for n equals 1. Showing the given statement is true for the first value, that is when n equals 1. Step 2 is an assumption. There we have to assume the statement, assuming the statement is true when n equals p. Here p is a positive integer. Second step is just an assumption. Step 3. There we are showing that the statement is true when n equals p plus 1 using this assumption. Step 3. Showing the statement is true when n equals p plus 1 using above assumption. Previously, if you have done some questions under principles of mathematical induction, you know these 3 steps. If you are a beginner, I will take an example to show what are these 3 steps. My example is, we have to show 3 to the power n minus 1 is a multiple of 2. So this is an expression. So this is what we call as a statement in this question. So this is the statement that I am going to show. It is a multiple of 2. That means it is divisible by 2. So first thing is to consider the statement 3 to the power n minus 1 as f of n. That is for our convenience. Now what is the first step? Showing f of n is true when n equals 1. When n equals 1. Then f of n becomes f of 1. f of 1 equals 3 to the power 1. Instead of n, I have to substitute 1. Then 3 to the power 1 minus 1, which is 2. Now it is clear 2 is a multiple of 2. Multiple of 2. Then I can conclude my step. First step. Therefore, f of n is a multiple of 2 when n equals 1. This is first step. Then second step, that is the assumption. We are going to assume this is true when n equals p. Assume that f of n is a multiple of 2 when n equals p. Then my statement becomes f of p, that is equivalent to 3 to the power p, because instead of n I have to substitute p. 3 to the power p minus 1. From this assumption we can state it is a multiple of 2. So I write 3 to the power p minus 1 as 2k, where k is an integer. If it is a multiple of 2, it can be 2 times any integer. That is the meaning of 2k. Now the third step. We have to show this is true when n equals p plus 1. For that we have to use this assumption. What is the assumption? This is equivalent to 2 times k. So this is third step. When n equals p plus 1. When n equals p plus 1. Then this becomes f of p plus 1. Now substitute p plus 1 for p. 3 to the power p plus 1 minus 1. Then what is the meaning of this 3 to the power p plus 1? That is 3 to the power p multiplied by 3 to the power 1. If you have these two powers to be multiplied, you know from a rule of indices, we can write this as same base 3 to the power sum of two indices p plus 1. So I can write this 3 to the power p plus 1 as 3 into 3 to the power p. Using this indices theory, I can write 3 to the power p plus 1 as 3 into 3 to the power p, and here we have minus 1. Then take this 3 out, because I have to take 3 to the power p minus 1 into a bracket, because for this bracket I can substitute 2k from our earlier assumption. But when we take 3 out from these two terms, we get minus 3. But in the expression we had only minus 1. Now we have minus 3. To change minus 3 to minus 1, I have to put plus 2. 3 into 3 to the power p, 3 into minus 1 becomes minus 3. Minus 3 plus 2, we have minus 1. Then 3 into, for this I can substitute 2k from our assumption, plus 2. Then I can take 2, the common factor, out from these two terms. We have 3k plus 1. Since k is an integer, 3k plus 1 is also an integer. Therefore, f of p plus 1 is written as 2 times an integer. 2 times an integer means f of p plus 1 is a multiple of 2. Because we could write f of p plus 1 as 2 times an integer. Therefore, using mathematical induction, for all positive integers, we can say f of n, which is equivalent to 3 to the power n minus 1, is a multiple of 2. This is how we show a mathematical expression, a mathematical equation, or any inequality is true.